morning, Ethan. I was going to do this last night. I've been trying to do better about doing school at school and home at home. But I was like, I was just exhausted last night for some reason. I don't know why. So I took everything home. I was like, I'm going to sit on the couch and do this. And then I just went to bed at like 6 o'clock. So I did not get it done. So again, it's getting done first thing in the morning. All right. So 2 5 notes about perpendicular lines. So we've got to get the formal definition of perpendicular lines is that it's two lines that intersect to form a right angle. All right, so this is tricky. People mess this up all the time when they're doing proofs because they'll try to jump from, like it'll say these lines are perpendicular, and they'll try to jump to the fact that that means the measure of their angle is 90 degrees. That doesn't. The definition says it's a right angle. So first you have to go, like you'd have to say, I know this is a right angle because of the definition of perpendicular lines, and then I know it has a measure 90 degrees because of the definition of a right angle. So a right angle is an angle whose measure is 90 degrees. All right, and as you already know, we put the little box to make 90 degrees. So here's a theorem. And this is, you were asking about this the other day. There's very few theorems that have a name. Like there's the angle bisector theorem, and there's the midpoint theorem. There's Pythagorean theorem. Like these are all things we can prove. And they show up so often that people actually gave names to them. Most theorems are just statements of fact that we prove. So, like anything that says theorem next to it, you're going to want to commit that to memory. So, if two lines are perpendicular, then they form congruent adjacent angles. So, if we prove it one time, you can go to, like, if they tell you got perpendicular lines, you can go straight to having congruent adjacent angles without having to reprove it every time. So, here's what we've got. So we have our given that NM, this looks weird, NM is perpendicular to JK. All right, so we're trying to prove that angles 1, 2, 3, 4 are all congruent. So what we would say is based off the definition of perpendicular lines, we know that angles 1, 2, 3, and 4 are right angles because of the definition of perpendicular lines. And did I say that? That's the symbol for perpendicular. If you didn't know, you can use that anytime you want. And then I could go through the whole rigmarole about, okay, each of those measures are 90 degrees, and therefore they all equal each other from substitution or transitive property. And then but we could also use that theorem that we've proven already in this chapter. Once you say they're all right angles, then I can say that angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4, because all right angles are congruent, because we've already proven that this chapter. Okay? All right, for the next part, turn the video off for just a second or pause it and see if you can find the correct sometimes, always, or never to fill in the blanks. Okay, so I assume that you did that. So let's check, see how you did. Perpendicular lines never form 60-degree angles. Two lines are perpendicular if and only if. So two lines are perpendicular if and only if they form congruent adjacent angles. We kind of just proved that. But it is a biconditional. So if you have two lines that do form congruent adjacent angles, then they also have to be perpendicular. So that is always true. Oh, by the way, I was very proud of you the other day when you were taking that test, when you were like, can I put IFF? Yes, you sure can. Because I know this sounds silly, but in math, that's not really considered an abbreviation. Like, that's just what it is. Like, we just don't want you doing things like PERP for perpendicular. But if you want to write that for perpendicular, by all means do it, because that's what that means. So, if you use a symbol or something that's, mathematically, oh, shoot, I just realized I forgot to clock in. Hang on. Start. Darn, I was actually here earlier. I guess it's okay. It says I'm here at 5:54, but I really got here at like 5:45, and that's making me sad. All right. So if the exterior, actually, I'm gonna tell her. This is so petty of me. Like, I need you to know that I was here for this extra. Oh man, it's making me time. I should pause it, but then I'd have to start over, and I'm not gonna. Okay, hang on. I need to tell. Clock in. Insert a comment. I actually got here at 5:45 a.m. I just forgot to clock in. I need people to know that I'm working harder than everybody else. I know it doesn't say much about me as a person. It's probably a bad thing that I need folks to know that. But I kind of do, and I'm okay with it. All right. So if the exterior sides of two adjacent angles are perpendicular, the exterior sides of two adjacent angles are perpendicular. Okay, let me draw a picture of it. So I got to have the sides being perpendicular, so that's got to happen, and then we got to have two adjacent angles. Then the angles are not supplementary; they'd be complementary. They're never going to be supplementary. Two perpendicular lines always or never or sometimes line with. Oh, it doesn't say two; it just says perpendicular lines. Okay, if it's two lines, definitely. That'd be an always. But if you had three, okay, if you had three perpendicular lines and they're all perpendicular to each other, ooh, okay, then you'd have, so two of them would have to be in the same plane. Because remember, any two lines are coplanar. But to have a third one perpendicular to these other two, it would have to go through the plane and be perpendicular like that. So if it's three lines, it would be never. So it's got to be sometimes. Okay. All right, next theorem. If two lines form congruent adjacent angles, ooh, I didn't put the comma, then the lines are perpendicular. All right, so we're going to take and say, here's our hypothesis. You've got two lines, drew it, they form congruent adjacent angles. So we're saying the angles 1 and 2 are congruent and adjacent. So that was given. All right. So, and then we got to prove that those lines are perpendicular. So this is one of those proofs, like, if you don't learn this theorem, like, you've got to go through all these steps every time. Like, you want to commit this theorem to memory. All right, so let's see what we can do. So we know that since those two angles are congruent, we know their measures are the same, because that's the definition of congruent angles. Let's see. What else do we know? Oh, we know that those two measures add up to 180 degrees because of the linear pair postulate. Okay. What if I plugged, since the measure of angle 2 equals the measure of angle 1, why don't I just plug that in here? So I could have the measure of angle 1 plus the measure of angle 1 is 180 degrees. And that's just a substitution, which that would be that two of those measures of angle 1 make 180 degrees, which is also a substitution. I'm not substituting from another line. I'm just substituting a value that equals another value. Like, I know by adding like terms, the measure of angle 1 plus the measure of angle 1 is twice the measure of angle 1. Then I could divide both sides by 2, and that would be because of the division property of equality. All right, and if the measure of angle 1 is 90 degrees, then angle 1 is a right angle, because that's the definition of a right angle. And if angle 1 is a right angle, that means that lines L, so we just proved that this is true. So line L is perpendicular to line N because that's the definition of perpendicular lines. All right, and then I've been trying to do my notes without looking at my notes because it's been a while since I've had to remember all these theorems. So I always try to go through them. But now that I'm going back and looking at my notes, I wrote some stuff in here. So from years past. So it was kind of like me leading my class through how we would have done this. A lot of times you look at what you want to prove. And so it's like if we can show that we had right angles, we'll have it. So I guess sometimes I don't have to do this because I've been doing proofs for so long, but this is kind of the way you want to think about it. It's like, okay, what am I trying to prove? Well, what would be the step before that? And I wrote another note over here. And I was like, okay, then the step before that would have been if we could show the measure of one angle being 90 degrees. Then we would have shown that we had the right angles, and we showed that we have the right angles, we show that we have perpendicular lines. Okay. Next step. So if the exterior sides of two adjacent acute angles are perpendicular, then those angles are complementary. And I remember in the past, like these are the three that my kids would always just forget until they realized they couldn't forget them. Like they'd be like, I don't want to memorize those three theorems because they're kind of wordy. But once we did enough proofs with those three theorems, they were just like, oh yeah, it's worth knowing because they didn't want to have to go through all the steps to get to that part again. All right, so we're trying, and I'm gonna, let's see, that's array. Just looks really weird. I don't know what happened. Oh, I do know what happened because I typed these up, 6 years ago or so, 5 years ago, and the version of Word now is different than the version of Word then. And so like when I downloaded it, it updated it to the new version, and that's why some of the stuff looks a little crazy. Okay. So if the exterior sides of two adjacent acute angles are perpendicular, so we're saying we've got these two adjacent acute angles, they're going to be perpendicular, then we've got to prove that the angles are complementary. So the way we're going to get there is if we can show that they add up to 90 degrees, that'll make them complementary. So like that's our whole goal, is how are we going to get to saying that those two angles right there are going to be add up, their measures will add up to 90 degrees. So let's see, we said they're perpendicular, that forms a right angle. So let's go ahead and say this, that angle AOC is a right angle because of the definition of perpendicular lines. Okay, if it's a right angle, we know its measure. Oh wait, I said AOC. No, that's right. AOC is the right angle. Okay. So we know that the measure of angle AOC is 90 degrees because the definition of a right angle. We also know, because we got through these two angles in there somehow, AOB, this one, and BOC, this one. So I know that those two measures add up to the measure of angle AOC because of the angle addition postulate. Then I can sub this in right here. substitution. And then since the measured angle AOB plus the measured angle BOC is 90 degrees, well, that's the definition of complementary angles. So now I can say, and I need to say it exactly like what it says to prove, that angle AOB and angle BOC are complementary angles because the definition of complementary angles tells me so. Ooh, that looks weird. Okay. And I think you've kind of hit the point now. Like, once you start doing proofs, the homework takes longer because, you know, a proof is not a fast thing to do. Like, it takes a while to think through it. And sometimes and when you check it, you're like, oh, I didn't do exactly what she did. Am I still right? Because sometimes you are. Like, sometimes we don't go through it the same way. Sometimes we might see it in a different light. So, if you're ever wondering, like, well, I proved it this way and she proved it that way, are we both right? Ask me, and I'll let you know. But, so, we're going to do these out of the book, and I think I've got it attached to it. I got to looking. It's like I had 2 different years. Like, one year I put the answers on it, and one year I didn't. I think the one I printed you off had the answers. Okay, so those are the answers. And then I'll also find the solutions and get those up. But I think you still have some stuff from yesterday to do. So make sure you get that done. And I think that's probably enough to keep us busy today.